unit we're about to, or the unit we are starting is on trigonometry. It's all about sine and cosine and that type of thing, but really the foundation of that is all in angles. So that's what we're going to talk about today is angles. So first let's just talk about different ways you can draw angles. So I'm going to draw what basically looks like a coordinate plane. And here's how we work this. This is the starting point over here, and it's 0 degrees. And then up here is 90 degrees. Over here's 180 degrees. Here's 270 degrees. And if you keep moving that direction, this can also be called 360 degrees. Goes all the way around. So I'm just going to draw an example angle. I'm going to do 135 degrees. So here's how I would draw it. I would draw it here to here. And I need to draw an arrow that way to let me know that that's the direction I went. Positive angles always move counterclockwise. That may seem strange, but if you can remember how the quadrants are numbered, which we'll come to later, but that's 1, 2, 3, 4. So if you just remember that that's the direction they go also, hopefully that'll help you remember. Now there's different parts of an angle that we need to talk about. First of all, the initial side. Okay, this is called the initial side. That's our starting point. Okay, if you notice, that's where our arrow originates from. Now this is the terminal side. That's where it ends. Terminal means ends. Terminate, you end something, so terminal is the ending side. You know, that's where our arrow ends. So that's our initial side and our terminal side. Okay, the point where those two sides meet is called the vertex. And what this is called is the standard position. Okay, let me write that out over here. An angle is in standard position when its initial side is on 0 degrees. So for example, this isn't going to be a really great drawing, but 135 degrees could also look something like this. Now that is 135 degrees, but it's not written in, or it's not drawn in standard position. Because standard position is only when you have your starting point on 0. So that just gives you an idea the difference there. Okay, let me take that off, highlight that again. Alright, so those are the parts of an angle. Its initial side, its terminal side, its vertex. Don't forget to draw the arrow so you know what direction you're going. And this one is written in standard position. Okay, so let's talk about different types of angles, and then we're going to look at how to graph a few of them on this. So first of all, an acute angle is an angle less than 90 degrees. A right angle equals 90 degrees. Or the measure of the angle equals 90 degrees, I think would be more correct. An obtuse angle is greater than 90 degrees. 135 would be an example, the one I drew up top. And then finally a straight angle is one that's exactly 180 degrees. So I'll just sketch really simple examples right next to these in green. So an example here would be something like this. That's acute. Right looks like this. You know, often we write that box in it to let you know that it's right. Obtuse would look something like this. And straight would just look straight. So those are the different types of angles. Alright, now we're going to talk about how to graph or draw these angles in standard position. Just make sure you're comfortable with it. Okay, so the key is to remember what the four corners are. 0, 90, 180, 270, and then back around to 360. Okay, that's the key. So one thing you need to know how to do is know which quadrant it's in. I won't be terribly picky on you getting the angles exact as long as you're in the correct quadrant. So for example, 45 degrees is what we're graphing here, and 45 degrees falls between 0 and 90, so that means it has to be in this quadrant, quadrant 1. So I would draw that, always starting on the 0, and then 45 degrees would be halfway, so I would draw it about like this. Don't forget the arrow going this way, and that would be my 45-degree angle, and it's in quadrant 1. Again, it goes 1, 2, 3, and 4. Goes counterclockwise, just like the positive angles. So the next one here is 225 degrees. So again, 0, 90, 180, 270, and 360. Okay, so 225 would fall in between 180 and 270. So it would start here, and it would go all the way around to somewhere between 180 and 270. We'll just draw it about there. And that would be our 225-degree angle. And it's in quadrant 3. Okay, now the next one we have is negative 135. So the negative ones go in the opposite direction. They actually travel clockwise. So if you want, you can label this, instead of using the positives, you can label it using negatives. So we still start at 0 here. We go the opposite way. So this is negative 90, negative 180, negative 270, and negative 360. Okay, so negative 135 would fall between negative 90 and negative 180. So it would be somewhere in this area, and the arrow has to go this direction. Excuse me. Alright, so then 405 is our last one. Okay, 0, 90, 180, 270, 360. So 405 is bigger than 360. So here's what's going to happen. It's going to start here, and it's going to go all the way around to 360, but then it's not done. It still has 45 more degrees to go, so I put it at 45 degrees above 360. Now it is important that you draw that spiral, because it goes all the way around and then ends 45 degrees after making one complete turn. So that's how you would draw those. Okay, so hopefully that gives you a good idea on how to draw them. The next part we need to talk about is something called coterminal angles. Okay, coterminal angles are angles whose terminal sides are at the same place. So let me give you a couple examples and see if you can find the pattern here. 90 degrees and negative 270 degrees. Okay, this would be one example. So let me draw this over here so you can see. I'll do 90 in red. 90 degrees would look like this. Sorry, that should be right on that line. And then negative 270 I'll draw in green. It would go all the way around this way, but end at the same place. So note, they're not the same angle. They just end the same place. One's going positive, one's going negative. One's a right angle, and one's way big because it's negative 270 big. So they're not the same angle. They just end the same place. So let me give you another example. Let's do 40 degrees and 400 degrees. These would also be coterminal angles. Okay, same idea. We'll do 40 in red. It would look something like this. Now 400 would go all the way around to 360 and then keep going 40 more degrees and be right there. So again, they're not the same. One's 40 and one's 400, but they do end in the same place. Now I want you to look at those two examples and see if you can see the relationship between coterminal angles. What is the difference between 90 and negative 270? And what is the difference between 40 and 400? And if you notice, both of them are separated by 360 degrees. So if you ever want to find a coterminal angle, all you have to do is either add 360 or subtract 360, which should make sense because 360 goes all the way around and you end up right back where you started. So coterminal angles are always separated by 360 degrees or a multiple of 360 degrees. I'm going to write that out for us. Coterminal angles are separated by 360 degrees or a multiple of 360 degrees. Because you could add 360 twice, which is adding 720, and those would still be coterminal. So any multiple of 360 would also work just fine. So one thing they may ask you to do is they might give you an angle that's either negative or really high and ask you to find a coterminal angle that's between 0 and 360. So let's try that. Find a coterminal angle between 0 and 360 degrees. Okay, I'm doing my best to remember to put my degree signs, but I apologize if I forget. So let's look at two examples with that. Let's say we have 420 degrees. Remember, they're always separated by 360, so it would make sense for this one for me to subtract 360, because I don't want it to go bigger, I want it to go smaller, I want it to be between 0 and 360. So to find the coterminal angle, I do 420 minus 360, which gives me 60 degrees. So 60 degrees and 420 degrees are coterminal. Okay, next let's do a negative one. Let's do negative 120 degrees. And in that case, we would add 360 because we want it to go positive. So we do negative 120 plus 360 degrees. And that's going to give us 240 degrees. So 240 and negative 120 are coterminal with each other. They have the exact same points where they end. So that is coterminal angles. Let's move on now to something called complements. Okay, so angles are complements of each other when they add up to 90 degrees. Alright, so first of all, I want you to note this is the word complements with an E, not an I. This is complement like complete or make better, or basically the idea here is if you pair two things, it's good. Hopefully husbands and wives complement each other well, or sometimes clothing complements each other well, or a dish complements another dish well. So this means helps by being added to. So complements add up to 90 degrees. Now, to have a complement, the angle has to be between 0 and 90 degrees. So complements are only acute angles. You can't use negatives or 0 to make a complement. Okay, so now if you look at these examples, it says find the complements for 62 degrees. Well, that's simple. I need to know what would make that add up to 90, so I just do 90 minus 62, and that would give me 28 degrees. So 28 degrees and 62 degrees are complements of each other because they are two acute angles that add up to 90 degrees. Okay, now for 120 degrees, that doesn't work. It's not acute. It's not between 0 and 90, so there is no complement for this angle. So complements are adding up to 90. CO, just remember, adds up to 90. Okay, next, angles are supplements if they add up to 180 degrees. To have a supplement, you must be between 0 and 180. So if it's 200 or 300 or 400 or negative, then you cannot have a supplement. Same idea here. Have to be less than 180 to have a supplement. So we're going to look at the same two angles. 62 degrees, so we do 180 minus 62 degrees, and that's going to give us 118 degrees. So 118 and 62 are supplements. They add up to 180 degrees. And then 120, we do 180 minus 120. We get 60 degrees. So this does have a supplement, even though if you look back, it did not have a complement, because it's less than 180, so it can have a supplement, but it wasn't less than 90, so it couldn't have a complement. Okay, I'm going to stop here and put the next section in another video.